Hey, geometry. We're going to work on unknown angles now. I always thought this was tons of fun because we can figure out the measurements of angles just by knowing the ratios of their sides. Okay, it's very cool. So let's go ahead and look at our lesson. So as an opening exercise, Dan was walking through a forest when he came upon a sizable tree. Dan estimated he was about 40 meters away from the tree when he measured the angle of the elevation between the horizontal and the top of the tree to be 35 degrees. Dan is about 2 meters tall. He said he was 40 meters away, right? And how tall is the tree? So I believe that's what we're looking at, right? This is 2 meters. So if we're trying to find x and we don't know the hypotenuse, because there's our right angle, we're going to need tangent. So tangent of 35 equals opposite over hypotenuse. Okay, cross multiply, and I have 40 times tan 35 equal to x. Do some multiplication here. 40 tan 35 is 28. So x equals 28 meters. But don't forget that we're missing this part right here. So the tree is approximately 30 meters tall. But we're not done yet. So Dan was pretty impressed with this tree until he turned around and saw a bigger one, also 40 meters away, but in the other direction. Wow, he said, I bet that tree is at least 50 meters tall. Then he thought a moment, if it is 50 meters tall, I wonder what angle of elevation I would measure from my eye level to the top of the tree. Right? Right there. What angle will Dan find if the tree is 50 meters tall? Now, I understand Dan is 2 meters tall, but let's just stick with 50 meters for the height of the tree and not worry about that 2 meters. It's just going to make our calculations a little bit easier. So, again, tan of x, because we don't know the degrees, is opposite over adjacent, which is 5/4, which is 1.25. So tan x equals 1.25. Well, we don't know what x is, and it's hard to get there, but that's actually what we're going to learn. What angle do you think it is? Do you think it's greater than 35 or less than 35? X is probably greater than 35 degrees because we're looking higher, right? This is going to be a bigger measurement. But let's talk about how to actually find the measurement, okay? So we have just a triangle here, a right triangle to be exact, our usual ABC. We know that sine of C equals opposite over hypotenuse. Cosine of C equals adjacent over a hypotenuse. Oops, so sorry. And tangent C equals opposite over adjacent. Okay? How about angle A? Sine A equals opposite over adjacent. Cosine A equals, sorry, I misspoke, opposite over hypotenuse. Adjacent over hypotenuse. And tangent A is opposite over adjacent. Alright, so amazingly enough, mathematicians have developed some additional terms to describe the angles with side ratios in the right triangle. Okay? So write this down. I'm going to move to a new slide and write something different down. Alright? Well, actually, I think I can fit it on here. Let's try that. So if I told you arc sine of AB over AC, what would that be equal to? Or arc cosine of BC over AC. What would that be equal to? Or even arc tan of AB over BC. What do you think that's equal to? Okay, let's look back over here. What is this? AB over AC. AB over AC. Well, that is sine of angle C. So arc sine of this is actually angle C. How about arc cosine of BC over AC? BC over AC. Arc cosine. Okay, so if I put this here, that there, we actually have the measure of angle C again. Or even arctan of AB over BC is going to be angle C. Right? So mathematicians use arctan, arcsine, and arccosine to refer to, let me write it down. So arcsine, arccosine, and arctangent refers to the angle measure that results in the given sine, cosine, or tan ratio. Okay, so arcsine, arccosine, and arctangent refer to the angle measures that result in the given ratio. Because remember, tan of some angle measure equals opposite over adjacent. This is a ratio. So what we're saying here is arctan refers to the angle measure that results in the given ratio. Okay? All right. Oh, one more thing. So I write it down here. In our calculators, we don't have arc sine. We have sine to the negative 1 of some angle. Okay? This right here, we said much earlier in the lessons on trigonometry that this is not equal to 1 over sine theta. Alright, so find the measure of angles A through D to the nearest degree. Okay, so we have angle A. This right here is a hypotenuse and an adjacent. Adjacent and a hypotenuse is cosine. Cosine of A equals adjacent over hypotenuse. So we can say cosine negative 1 of 13 over 20. Type that into our calculators. So I'm typing cosine negative 1, 13 divided by 20, and hitting enter. And what's getting spit out is 49.5 degrees. Okay, go ahead and try that out. See if you can get the right answer. Sorry, it's so loud in here today. It's after school, if you can't tell. So there's my hypotenuse. And I have an opposite in a hypotenuse. So I'm going to use sine of angle B equals opposite over hypotenuse. So that means arcsine of 40 over 42 equals sine of the negative 1, 40 divided by 42, enter, 72.2 degrees. Pretty simple? Yeah. Okay, why don't you guys try these two on your own, and then check your answer in a sec. Okay, for part C, you see our answer is 25.8 degrees. For part D, I used sine. You could actually use cosine or tangent. So I would have cosine is 51 over 85, so it would be cosine negative 1. You get the same answer. Or arctan, which would be opposite over adjacent, 68 over 51, and you would get the same answer. Okay, I just picked sine for some reason. All right, Let's try another one. Shelves are being built in the classroom to hold textbooks and other supplies. The shelves will extend 10 inches from the wall. Support braces will need to be installed to secure the shelves. The braces will be attached to the end of the shelf and secured 6 inches below the shelf on the wall. What angle measure will the brace and the shelf make? So we have the brace and the shelf. What is x? All right, so we don't know our hypotenuse, but we can figure out what x is by using tangent. So tangent of x equals opposite over adjacent. So tan negative 1 of 6 over 10 is 31 degrees. A 16-foot ladder leans against a wall. I have a wall. And then I have a ladder. Ooh, that's bad. A 16-foot ladder leans against a wall. The foot of the ladder is 7 feet from the wall. Find the vertical distance from the ground to the point where the top of the ladder touches the wall. So we need, this value right here. I'm going to go ahead and use Pythagorean theorem. 7 squared plus x squared equals 16 squared. And that gives me 14.4 feet. All right, so the ladder is about 14.4 feet from the ground. Determine the measure of the angle formed by the ladder and the ground. So I think we want this value right here. We'll call that y. And it doesn't matter what numbers I use now. I can use anything. I'm going to go ahead and use tangent. I don't know why. Tangent gets left out a lot, So tan to the negative 1, or arctan, opposite over adjacent. So 14.4 over 7. You can go ahead and check it out. We might get slightly different answers because of rounding issues. I got 64.1 degrees, so about 64 degrees. Right, a group of friends have hiked to the top of the mile-high mountain. When they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. Mile-high mountain. Awesome. When they look down, they see their campsite. We're going to make their tent in yellow. Okay, it's a little teepee tent with a door in it. And this is about 3 miles. They know that because they hiked it. I should have made that green. Oh, yeah. So from here to here, we're about 3 miles. Let's see, what else do we know? So sketch a drawing of the situation. Check, all done. We're actually going to try to do, let's see. Let's try to ease our math a little bit. All right. So first we are wondering about the angle of depression. Okay? So that means from up here, they're wondering, let's see if I can draw that. Okay, that right there is the angle of depression. So let's see. We know from our study of parallel lines, so the ground and the sky are parallel, so we would consider this a transversal. This measurement right here is the same as this angle measurement right here. So this is also going to be theta. Those are alternate interior angles, so they're equal. So our angle of depression will be the same as our angle of elevation from the campsite to the top of the mountain. So we can say tan -1 of opposite over adjacent. Oh, wait a minute. Let me draw something. I think I might be wrong in my 3/1. This is also 1. So this theta tangent's going to be opposite over adjacent. Nope, I'm good. 1/3. Nope, now I'm in different colors. Yep, excuse me. About 18.4 degrees. That was sort of fun. The drawing really helps though, doesn't it? Especially the color coding, the sky, the grass, the campsite. A roller coaster travels 80 feet off track from the loading zone before reaching its peak. So we have its peak. The horizontal distance between the loading zone and the base of the peak is 50 feet. And about 80 feet off track from the loading zone before reaching its peak. Model the situation using your right triangle. That's tough. So the roller coaster travels 80 feet from the track before reaching its peak. Okay, so it's going up 80 feet before it reaches its peak. The horizontal distance between the loading zone and the base of the peak is 50. Okay, so I have a modeling using your right triangle. At what angle is the roller coaster rising according to the model? So really, what is this? It looks like I have a hypotenuse and an adjacent. So I want cosine -1, 50 over 80. Let's see, cosine -1, 50 divided by 80. That gives me an angle of elevation of 51 degrees, 51.3 approximately. So that was fun. I think you find your problem set pretty okay. That's all for today, though.